Inside silicon, the technology behind everything.
From the phone that's probably in your pocket right now to the massive servers that run the internet, pretty much every piece of modern tech runs on this tiny, tiny engine, the semiconductor chip. They are the invisible bedrock of our entire digital world, and they've been driving just unbelievable progress for decades. And just to give you a sense of the sheer scale we're talking about, get this. In 2021, the global market for these chips hit a record-breaking $555.9 billion. Yeah, this isn't just some big industry, it's a foundational pillar of the entire global economy. But here's the catch. This engine, this incredible model of constant, relentless improvement that has basically defined our entire technological era, is about to hit a fundamental physical wall. The very rule that made it all so powerful, it's starting to break down. And that brings us right to the heart of the problem. We are witnessing the end of an era that was governed by a simple but incredibly powerful observation known as Moore's Law.
For more than 50 years, Moore's Law has been the steady heartbeat of the tech industry. The idea was simple. You just cram more and more transistors into the same amount of space. And by doing that, we made our devices exponentially faster, smaller, and way more power efficient. It is the single biggest reason why your phone today is literally more powerful than a supercomputer from just a few decades ago.
And this shrinking process, it's been just dramatic. Back in the 80s, we were working at 1,000 nanometers. Fast forward to 2022, and the most advanced chips were being built at the 3 nanometer scale. That level of miniaturization it's kind of hard to even wrap your head around.
But here's the thing, we're running out of room. When your components are only a few atoms wide, you start bumping up against the really weird rules of quantum physics. You just can't keep shrinking things forever. So that era of easy scaling, it's over. So that leads to the million-dollar question, right? If the industry's entire playbook for the last half-century has been just make it smaller, what on earth do you do next?
Well, the answer, as it turns out, is to change direction. If you can't build out anymore, you've got to build up. Welcome to the new world of three-dimensional chips.
Let's think about it like this. For decades, we built chips like big, sprawling, single-story ranch houses. Everything was flat, all on one level. The new way? It's to build like a skyscraper. Instead of one huge, complicated design, you create smaller, specialized blocks. We call them chiplets, and you stack them vertically, one on top of the other.
What this does is it allows for a totally modular approach. So you can have one chiplet for the main processor, another for graphics, and maybe another one for memory. Each one can be made with the absolute best technology for its specific job, and then you just connect them all together into a single, super powerful 3D tower.
And this 3D method doesn't just get us around the physical limits of shrinking. It's actually way more efficient. See, it's a lot easier to manufacture a bunch of small, perfect chiplets than it is to create one gigantic, flawless chip. This seriously boosts the manufacturing success rate, what the industry calls yield, and that ultimately brings down costs.
Okay, but like with any revolutionary technology, this whole new 3D world, it comes with its own monumental set of challenges. Let's be honest, building a skyscraper is a whole lot more complicated than building a ranch house.
To really get what's at stake here, we have to talk about that key metric I just mentioned, manufacturing yield. It's simply the percentage of working, perfect chips you get from a single silicon wafer. In a business that runs on billion-dollar factories, a low yield isn't just bad, it's an absolute catastrophe.
And right here is where the stakes become crystal clear. For the most advanced 3-nanometer chips, the industry leader TSMC is reportedly getting over a 90% yield. Meanwhile, Samsung has apparently struggled to get past 50%. Think about that. That means for every 2 chips Samsung makes, one of them could be a total dud. It just shows you how incredibly difficult this new 3D manufacturing really is.
Now, this isn't just a technical problem. It's a full-blown business crisis. As one industry expert put it, trust is absolutely critical. When your yields are that low, major clients, we're talking Google, Qualcomm, NVIDIA,
They get really nervous, and they start moving their multi-billion-dollar orders to someone they know can deliver.
And believe it or not, the manufacturing headache is just the beginning. The skyscraper analogy really holds up here too. You have all these new problems. How do you get power all the way up to the penthouse? How do you get heat out from the middle of the building so it doesn't melt? And maybe most important, how do you make sure all the elevators connecting those floors are perfectly reliable for the next 10 years? These are the new frontiers of engineering.
So solving these massive problems, it's going to take more than just better factories. It requires a completely new way of thinking about how we design chips in the first place. We basically need a whole new set of blueprints.
You see, a huge piece of this puzzle is that the software engineers used to design chips, the so-called EDA tools, was all built for a flat 2D world. Trying to use those tools to design a complex 3D chip, well, it's like trying to use the blueprints for a ranch house to build a skyscraper. It just doesn't work. It's the wrong tool for the job.
And this is exactly where projects like Coin3D come into play. It's this big collaborative effort between several European universities, and their whole goal is to build the actual tools, the open source architectural software that we need to design and test these incredibly complex 3D systems.
Their mission is pretty straightforward, but it's also incredibly ambitious. First, they have to figure out how to even design for reliability in a 3D stack. Second, build the open source software so anyone can use it to do that. And finally, use this whole project to build up expertise and really strengthen technological independence in Europe. So you see, they're not just solving a technical problem, they're trying to build an entire ecosystem for the future.
So as the long reign of Moore's law fades away, and the semiconductor industry starts reaching for the sky, the race is truly on. It's not just about who can build the smallest part anymore. It's about who can design the smartest, most reliable skyscraper. And the blueprints for that future, they're being drawn as we speak.
Inside silicon, the technology behind everything.